A chemical engineer is researching how temperature affect product yield. The product is executed for 16 times. In addition, percent of a theoretical maximum is used as a unit of measurement for yield. There are some problems that may occur during the chemical process which may affect the results of the data. Firstly, errors that normally happen during the experiment, which is parallax error. This is caused by our eyes is not aligned to the measuring scale, and this will affect the data. Moreover, confounding variables, sometimes it's also known as mixing effects, occurs when the effects of the exposure we study on a certain outcome are combined with the effect of another factor. There are some needs that are necessary while conducting the study. First, we have to ensure that the measurement of the study and yield must have to be accurate by calibrating apparatus regularly. It is to avoid any calibration error. Lastly, comprehensive experimental design. This is because the study requires a wide range of temperatures, which is 110 degrees Celsius to 143 degrees Celsius, which is to determine the relationship between two variables, which is temperature and the percentage of yield. Thus, this study highlights the importance of temperature control in various chemical processes to enhance product yield and quantity.
Second is the objective of this study. The first one is to identify the relationship between the temperature and the percentage of yield, where the independent variable is the temperature and the dependent variable is the percentage of yield. The second one is to develop a linear regression model between the temperature and the percentage of yield. And lastly is to predict the percentage of yield based on a linear regression model. Third is the significance of this study. Chemical engineering studies on the effects of temperature on product yield offers significant benefits to knowledge and industry. Research has shown that temperature optimization can maximize yields in various processes, including distillation, autocatalytic reactions, which involve catalysts, and olefin production, where the most common method for producing olefins is steam cracking, which involves heating alkenes and steam to high temperature to break the alkenes into shorter chain of hydrocarbon. For instance, in ethylene production, an optimal coil outlet temperature of 1128 Kelvin was found to maximize income. Temperature control combined with other process modifications such as product recycling and equipment design can substantially improve product yields. In chlorobenzene production, process modification increased yield from 83 to 98%. These studies contribute to the development of more efficient and economical industrial processes, potentially reducing energy consumption and waste generation. By expressing yield as a percentage of theoretical maximum, researchers can effectively compare and optimize different processes, leading to improved production efficiency across various chemical engineering applications. Thus, a higher yield of product is generally better because it can save time, effort, and resources. A high percentage yield is important in industrial production because it can help minimize waste and unnecessary products. Lastly, the last subtopic of Chapter 1 is the limitation of the study. Research using secondary data sources such as books presents several limitations. The limitation of the study is that no session for asking questions can be made to prove more about the accuracy of the data, since the data is already published in a book. Next is outdated information. If the book is older, the information may be not reflective of current knowledge or advancement in the field.
Data description. Description of data. Data shows a chemical engineer studying the effects of temperature on the yield of a product. The units for yield are expressed as a percentage of a theoretical maximum. For the variable of interest, for independent variable, x is temperature in degrees Celsius. For dependent variable, for y, is yield in percentage. For the sample size is 16 observations. Graphical technique. Type of graph to be used in this study is scatter plot. Scatter plot is a two-dimensional graph that plots the individual values of a data set. This diagram plots a pair of values at x and y coordinate. The scatter diagram forms a certain pattern, increasing or decreasing, indicating that there is a relationship between the two variables. If the scatter diagram does not show any pattern or randomly scattered, we assume that the two variables do not have a relationship between them.
Next, numerical technique, the descriptive analysis. Mean. Mean is the average of the data values. First, grouped data. Mean equals to total effects over n. Total effects indicates the frequency times with midpoint, where n is sample size. Next, ungrouped data. Mean for ungrouped data equals to total x over n, where the total x indicates the sum of the total given data, while n is sample size. Next, median. Median is the middle value of the original data in ascending order. First, for grouped data, median equals to LM, which is the lower boundary of the class median class, plus, open brackets, total f over n minus with cumulative frequency before median class over frequency for median class, close brackets, times with class size. For ungrouped data, we need to find the location of median first, which is n plus 1 over 2. Then we arrange the data in ascending order to find the location of median. Then lastly, locate the median value from the arranged data, hence determine the median value. Then mode. Mode is the data that occurs the most frequent. For ungrouped data, mode is equals to L, which is the lower boundary for the mode class, plus, in open brackets, F0, F0 minus F1, which is frequency of mode class minus frequency before mode class, over, in brackets, frequency for mode class minus frequency before mode class, close bracket, plus with frequency of mode class minus frequency after mode class, close bracket, times with class size. For ungrouped data, compute the number of times the value of the data that occurs the most frequent. Next, method of correlation. Bayesian correlation coefficient. It is used to measure the strength of the relationship between two quantitative variables. So, when the value of R or correlation coefficient is close to negative 1.0, it shows that it has a strong negative correlation between the two variables. This means it has increase in one of the variable that causes the other one to decrease. While when the value of R is close to 1.0, it shows that it has a strong positive correlation between the two variables. This means there is an increase in one of the variable, this also will cause the other one to increase. But when R equals to 0, it shows that there is no linear relationship between the two variables. Next, the coefficient of determination, which is R squared. So what is the coefficient of determination? The proportion of the total variation in the dependent variable that is explained by the variation of the independent variable. The formula is the square of the product moment correlation coefficient, where it takes only positive value which lie between 0 and 1. The higher the value of R squared, the more helpful X variable in predicting variable Y. Next, method of regression analysis. For intercept, the point on the y-axis where x equal to 0. If the scope of the model include x equal to 0, intercept give the mean of y at x equal to 0. If the scope of the model does not include x equal to 0, intercept does not have any particular meaning. For slope b, which is each additional increase in variable x, there will be an increase or decrease in variable y. So first, when the b is positive signs, it shows that x increase, then y will increase. But when b is negative sign, x increase, y will decrease. But when b is equals to 0, then the two variables are not related. So next, chapter 3, result and discussions. First, data presentations. So in this data, shows that the temperature and percentage of yield. The minimum value for temperature is 120 degrees Celsius and maximum value for temperature is 143 degrees Celsius. The minimum value for the percentage of the yield is 69.56% and maximum value for the percentage of the yield is 83.03%. Next, scatter plot from SPSS. Scatter plot shows the relationship between temperature and yield. So, as we can see, it shows that it has moderate positive correlation between the temperature and percentage of yield because it's scattered in ascending order. Means that when the temperature increases, the percentage of yield also increase. The linear regression equation shown in the table in the scatter diagram, which is y equals to 44.31 plus 0.2609x.
Let's start with descriptive statistic analysis. First of all, mean of temperature. We have to write the formula first, which is mean equal to total of x over n, and the value of total of x is and the answer is 119.88. So that for interpretation, the average of temperature is 119.88 degrees Celsius. Let's continue with mean percentage of yield. First of all, we have to rewrite the formula just like just now, which is as mean equal to total of x equal over n, and the answer is 75.59. For the interpretation, the average percentage of yield is 75.959%. Next, median of temperature. First, we have to locate the location of median by use this formula, which is location of median equal to n plus 1 over 2, 8.5, and the location and which is between of 8 and 9. We have to plus it and over with 2 and divide it with 2, which is 114 plus 117, which is the value we got from the location that we get just now, over 2, and the answer is 115.5. For the interpretation, 50% of the temperature is less than 115 degrees Celsius, while another 50% is more than 115.5 degrees Celsius. Lastly, median or percentage of yield. Just like I did just now, we have to locate the location of median of percentage of yield. 1 plus 1 over 2. The answer is 8.5, which is the location is between 8 and 9 of the data. For the value of median, the value is 69.56 plus with 74.41, and we divide it with 2, and the answer is 71.99. For the interpretation, 50% of the percentage of yield is less than 71.99%, while another 50% is more than 71.99%. For MOHD, there is no value of MOHD in the data because all the observation occurred twice.
Next, let me explain about the correlation and regression analysis. First, the correlation coefficient based on the formula. Correlation coefficient is Bayesian correlation coefficient that is symbol as R. So, R equals to total xy minus
total x times with total y divided with n, which is the sample size, over the products of square of total x square minus in brackets total x square over n times with total y square minus in brackets total y square over n. So let's solve this problem. The answer is 0.7323. So what is the interpretation? Interpretation is there is a moderate positive relationship between temperature and yields. Why is moderate? Because below the 0.8 it is moderate, while 0.8 upwards is strong positive, while 0.5 below is weak. So next, let's find the coefficient of determination based on formula. You can get it from R that we got last time. So R equals to 0.7323. So the coefficient of determination is R square, and we got the answer 0.5363, the R square, which is 53.63%. So the interpretation is 53.63% of the total variation in yield can be explained by temperature.
Next, output from SPSS, the summary table. It shows that it has space-time correlation coefficient, R, which is 0.732, where it means the moderate positive relationship between temperature and percentage of yield, because the value is less than 0.8. This also shows that the coefficient of determination is 53.63% of the total variation in the yield can be explained by the temperature. And in the correlation table, indicates the sample size in data, which is 16 observations.
Next, let's find out or solve the problem regression analysis. First, the intercept, slope, and the regression equation. So, to find intercept, which is A, we need to find the slope first, which is B. So, what is the equation? So, B equals to total xy minus total x times with total y divided with n over total x square minus in brackets total x and square outside. So, over the value in this formula. B will be equal to 0.2609. So, it is a positive slope. So, the interpretation is every 1 degree increase in temperature, the yield also will be increased by 0.2609%. Next, intercept A. As I say, we need to find the slope first, then intercept y. Let's see the formula. A is equals to total y over n minus with b, which is the slope, times with total x over n. So let's solve this problem with the given value. So the answer is A is equals to 44.31. So the interpretation is when the temperature is equal to 0, then the percentage of yield is 44.31%.
Next, regression equation. So the formula is y equals to a plus bx. This is similar to y equals to mx plus c. So let's substitute a that we got, which is 44.31, and b, which is 0.2609. So the regression equation will be y equals to 44.31 plus 0.2609x. Next, output from SPSS. So based on the output from SPSS, which is the ANOVA table, indicates the significance for model fit p-value of our data is 0.01. This model fit as the p-value should have a value that is less than equal 0.05. So this means there's a statistical difference between temperature and percentage of yield, and we also meet the best model fit. Next, the coefficient table. The coefficient table shows the constant unstandardized, which shows the value of intercept A, which is 44.310, same with what we got, and the temperature unstandardized shows the value of slope B, which is 0.261, which is the round up of what we got, which is 0.2609. This shows the positive value of slopes. That means if temperature increases, then the percentage of yield will also increase. Next, break the dependent variable based on the regression model, run 3 experiment data, and explain the result of yield. So first, let's use y equals to 44.31 plus 0.2609x that we got. When the temperature is equals to 117 degrees Celsius, we substitute x into the formula, and we will get 74.84%. Next, when the temperature is equals to 120 degrees Celsius, we got 75.62%. Lastly, when the temperature is equals to 128 degrees Celsius, we will get 80.31%. So, for the explanation of the result of yield is, the regression model will predict when temperature at 117 degrees Celsius, the percentage of yield product is 74.84%. The regression model predicts when temperature at 120 degrees Celsius, the percentage of yield product is 75.62%. The regression model predicts when temperature at 128 degrees Celsius, the percentage of yield product is 80.31%.
In conclusion, we identified the relationship between the temperature and the percentage of yield as a moderate positive correlation that is proven in the scatter plot graph. Furthermore, the relationship between these variables can be settled more by using Pearson product moment correlation coefficient R. The value of R in the study is 0.7232, that is close to 0.1, which is that indicates the strong positive correlation between the temperature and the percentage of yield. This means that when the temperature of the product increases, the percentage of yield increases as well. Based on the scatter plot, y equal to 44.31 plus 0.2609 as we find that 44.31 is the value of of the intercept of A when the temperature is equal to 0, while 0.2609 is the value of the slope of B that will be increased for every 1 degree Celsius. Hence, based on the linear regression equation, we also could predict the percentage of it for any value of temperature in this study, which is related to the higher value of the coefficient of determination R square, the more efficient the temperature is in predicting the percentage of yield. Based on the ANOVA table, the null hypothesis should be rejected as the p-value is less than 0.01, generally regarded as statistically significant. All in all, the objective in the study, which is the relationship between the temperature and the percentage of yield, are achieved.
Recommendation. For future work, it is recommended to explore the factors that may influence the yield of a product. The first factor is limiting reactants, because the amount of limiting reactant will determine the maximum theoretical yield. Other than that, reactants may undergo other reactions in addition to the desired reaction, which can decrease the yield of the desired product. Furthermore, there will be unconsumed reactants when the reaction is incomplete. And lastly, we can also use primary data such as dry ride observation so that the result is more accurate and variables are easily identified.